Can you open a little bit?
Do what now?
Yeah, just increase the size of the words.
Okay. Is that better?
Yeah, that's better. That's perfect. And we have to read also the topic or the title of the paper. So let's do it.
Let's do it, huh? Entropy or
No,
virtual?
just the article.
Okay, are virtual particles less real? Looks like Greg Jaeger. Quantum Communication and Measurement Laboratory, Department of Electrical and Computer Engineering, and Division of the National Science and Mathematics, Boston University. Abstract. The question of whether virtual quantum particles exist is considered here in light of previous critical analysis and under the assumption that there are particles in the world as described by quantum field theory. The relationship of the classification of particles to quantum field theoretic calculations and the diagrammatic aids that are often used in them is clarified. It is pointed out that the distinction between virtual particles and others, and therefore judgments regarding their reality, have been made on the basis of these methods rather than on their physical characteristics. As such, it has obscured the question of their existence. It is here argued that the most influential arguments against the existence of virtual particles, but not other particles, fail because there either are arguments against the existence of particles in general rather than virtual particles per se, or are dependent on the imposition of classical intuitions on quantum systems, or are simply beside the point. Several reasons are then provided for considering virtual particles real, such as their descriptive, explanatory, and predictive value, and a clearer characterization of virtuality. One in terms of intermediate states that also applies beyond. Did I miss a line there?
No, that's okay.
Oh, that also applies beyond perturbation theory is provided. It is also pointed out that in the role of force mediators, they serve to preclude action at a distance between interacting particles. For these reasons, it is concluded that virtual particles are as real as other quantum particles. Keywords: quantum field, elementary particle, quantum, scattering, perturbation theory, ontology, virtual particle.
Yeah, that's okay. Let's move to the next document.
How did I do?
You just yep, that's it. But if you increase the size of the letter, that would be great. Thank you.
All right, something happened on the real, the actual, and the virtual and elementary particle physics. Arkady Plodinsky, I'm not sure I pronounced that correctly, but abstract. Throughout the history of quantum theory, an elementary particle has been a problem to which only fragments of a possible solution could be offered. At a certain point of this history, a virtual particle has become part of this problem. While still considering this problem as a problem, this article, in contrast to most approaches to it, which are realist in nature, offers a non-realist one. This approach is grounded in the concept of reality without realism, RWR, introduced by this author previously, and an interpretation of high energy quantum phenomenon and quantum field theory, QFT. Grounded in this concept, which allows for a range of RWR type interpretations, the status of real and virtual particles is different in the present interpretation. While in this interpretation, both concepts are idealizations, that of real particles is required by it. By contrast, the concept of virtual particles is not required, although because of certain observable effects in high energy quantum regimes, this interpretation assumes that there exists something in nature, especially manifested in high energy quantum regimes, that may be handled by means of the concept of virtual particles. RWR type interpretations do, however, permit an idealization defined by this concept and may adopt it because of its practical effectiveness. This article will do so while still maintaining the essential difference in the nature of the idealization defined by the concepts of real and virtual particles.
Yeah, let's move to the next.
Okay. How do I get to the next one?
Yeah, there you go.
What happened to it?
Just click it again and it is going to appear. And can you increase a little bit the size? Thank you.
Want me to read this title up on top here?
Just, yeah, from there. That's okay.
Exploring human-guided strategies for reaction network exploration, interactive molecular dynamics and virtual reality as a tool for citizen scientists. Abstract. The emerging fields of citizen science and gamification reformulate scientific problems as games or puzzles to be solved. Through engaging the wider non-scientific community, significant breakthroughs may be made by analyzing citizen-gathered data. In parallel, recent advances in virtual reality, VR, technology are increasingly being used within a scientific context in the burgeoning field of interactive molecular dynamics in VR. IMD/VR allows users to interact with dynamic chemical or chemistry simulations in real time. Here we demonstrate the utility of IMD VR as a medium for gamification of chemistry research tasks. IMD VR game was designed to encourage users to explore the reactivity of a particular chemical system. A cohort of 18 participants was recruited to play test this game as part of the user study. The reaction game encourages users to experiment with making chemical reactions between a propane molecule and an OH radical, and molecular snapshots from each game session were then compiled and used to map out reaction pathways. The reaction network generated by users was compared to the existing literature networks, demonstrating that users in VR capture almost all the important reaction pathways. Further comparison between humans and the algorithmic method for guiding molecular dynamics show that through using citizen science to explore these kinds of chemical problems, new approaches and strategies start to emerge.
Yes, that's okay. We can move to the next.
Thank you.
Are you okay?
Yeah, I don't know what I'm talking about, but I'm sure you do.
Yes.
All right. What am I reading? The introduction here?
No, this the first part. The
Okay. An experimental information gathering and utilization systems, IGUS, robot to demonstrate the physics of now. Ronald P. Gruber, Stanford University Medical Center, Stanford, California. Ryan P. Smith, Department of Physics, California State University, East Bay, Hayward, California. The past, present, and future are not fundamental properties of Minkowski spacetime. It has been suggested that they are properties of a class of information gathering and utilizing systems, IGUSs. The past, present, and future are psychologically created phenomenon that not actually properties of spacetime. A human is a model IGUS robot. We develop a way to establish that the past, present, and future do not follow from the laws of physics by constructing robots that process information differently and therefore experience different nows or presents. We construct a customized virtual reality, VR, system which allows an observer to switch between present and past. This robot or human with VR system can experience immersion in the immediate past ad libitum, being able to actually construct an IGUS that has the same present at two different coordinates along the world line lens support to the IGUS hypothesis.
what do you think? We can continue to the next.
I'm trying to figure out how all this ties together somewhere.
Uh-huh.
All right. About as big as that one's going to get.
What can you say that again?
It's about as large as this one's going to get. I can't zoom it in.
Yeah, that's okay. That's okay. I still can read it.
Okay, what am I starting here with the LEDs?
Yeah.
LED lighting, ultra low power lighting schemes for new lighting applications. Mark Fontoynant, Danish Building Research Institute, Aalborg University, Copenhagen, Denmark. In 2018, solid state lighting, SSL, can totally outperform, if properly designed, most of other lighting products used for general lighting applications. This concerns various attributes such as luminous efficacy, life, spectral qualities, dimming potential, and more total cost of ownership. SSL can also mimic a large variety of reference light sources from candlelight to sunlight. The absence of international standards concerning LED modules remains a major difficulty for luminaire manufacturers and their clients, since perfectly matching replacement of ever-changing LED modules is not guaranteed over time. For extraordinarily innovative lighting schemes can be developed, bridging the gap between the world of entertainment and the world of general lighting, and leading to new lighting schemes with more powerful emotional content. LED sources, mostly DC driven, also can benefit from progress in photovoltaics and batteries, as well as wireless control to offer integrated solutions. This could radically change the operation of lighting in the next 10 years.
Yes, we can continue.
You got more?
Let me see if there is. Yeah, there is one more.
Am I reading the introduction or no?
No, just the first part.
I don't have to pronounce all these Chinese names, do I?
No, it's not necessary. Just the title, and then we continue with the first paragraph. Those
Okay.
names are not important.
All right.
Really. Yeah.
GATE Monte Carlo simulation of GE Discovery 600 and the uniformity phantom. GATE stands for GANT4 application tomography emission. Monte Carlo simulators have been successful in the application of emission tomography for precise modeling of various physical processes. Most previous studies of Monte Carlo simulations have only involved performance assessments using virtual phantoms. Although that allows for performances simulated positron emission tomography, PET, to be evaluated, does not reflect the reality of practical conditions. This restriction causes substantial drawbacks in GATE simulations of real situations. To overcome the described limitation and to provide a method to enable simulation research relevant to clinically important issues, we conducted a GAT simulation using real data from a scanner rather than a virtual phantom and evaluated the scanner is performance. For that purpose, the system and the geometry of a commercial GE PET/CT or computed tomography scanner, VGO based Discovery 600 or D600 was developed for the first time. The performance of the modeled PET system was evaluated by using the National Electrical Manufacturers Association, or NEMA, NU 2-2007 protocols, and results were compared with those of reference data. The sensitivity, scatter fraction, noise equivalent, count rate, NECR, and resolution were estimated by using the protocol of the NEMA NU 2-2007. Sensitivities were 9.01 CPS per, I don't know what that stands for. What's KBQ stand for? Anyway, at 0 cm and 9.43 CPS per KBQ at 10 cms. Scatter fractions were 39.5%. The NECR peak was 89.7 kCPS at 14.7 KBQ/cc. Resolutions were 4.8 millimeters in the transaxial plane and 5.9 millimeters in the axial plane at 1 centimeter and 6.2 millimeters in the transaxial plane and 6.4 millimeters in the axial plane at 10 centimeters. The resolutions exceeded the limited value provided by the manufacturer. The uniformity of phantom was simulated using the CT and the PET data. The output data in a RUT format were converted and then reconstructed by using the C program and STIR, or software for tomographic image reconstruction. The reconstructed images of the simulated uniformity phantom data had comparable quality, even through improvement in the quality it still required. In conclusion, we have demonstrated a successful simulation of a PET system by using scanned data. In future studies, the parameters that alter the imaging conditions, such as patient movement and